All right, today we're talking about average atomic mass. So you have an element and it has three different isotopes with differing atomic masses. One has an atomic mass of 19, one has an atomic mass of 24, and one has an atomic mass of 20. And we see the abundances on the right-hand side of this table right here. So we need to figure out what the average atomic mass of this isotope is. And the way that we do that is we take a weighted average of all of these isotopes. And in order to do that, we multiply the abundance of the isotope by its atomic mass, and we sum up all the isotopes. And so we simply do 12% times 19 plus 28% times 24 plus 60% times 20. And when you do this on a calculator, you get a value of 21. So this would be the average atomic mass of this mystery element of X. Now, what if we have another molecule? We will call that mystery molecule A. So A has an isotope with an atomic mass of 6 and an isotope with an atomic mass of 7. The one with 6 has an abundance of 30%, and the one with an atomic mass of 7 has an abundance of 70%. Now, A forms a diatomic molecule. And you can think about oxygen, right? Oxygen forms a diatomic molecule, O2, and you could do this with any given element, but we are going to figure out the abundance of the isotopes of the diatomic molecule of O2. And so, first thing that we have to do is figure out the different weights that A2 will form. And so the first weight would be a mass of 12, because you just add 6 and 6 and you get 12. The second one will be 13, because this would take in one with weight 6 and one with weight 7. And then the third one is 14, because it's two elements of atomic mass of 7. And now, to get the abundance of these diatomic molecules, we simply need to figure out the percentage of time that two 6s will combine. And since 6 occurs 30% of the time, we can simply do 30% times 30%, which gives us 9%. And we can do the same thing for 14. We do 0.7 times 0.7, and that is equal to 49%. And then this 13 gets a little bit tricky because there's two ways that 13 can be formed. We could think about a 6 and a 7 combining, or a 7 and a 6 combining. And so we're going to have to add up the probabilities of these two things happening. And so the first one has a probability of 0.3 times 0.7, which is equal to 0.21. And then the second one has a probability of 0.7 times 0.3, which is equal to 0.21. And so we add these two together because there's two different ways that it can form, and we get 42%. And we do a quick check to see that 9 plus 42 is 51, plus 49 is 100%. And so that's how we know that these abundances are correct. Hopefully this was a little bit helpful.